Have you ever heard of Arnold Sommerfeld? If the name doesn't ring a bell, you're not alone. But what if I told you that this unsung hero of physics might be the greatest teacher you've then never heard of? He mentored more Nobel Prize winners than almost anyone in history, and was nominated for the Nobel Prize himself a staggering 84 times. Yet, he never won. So, who is this incredible mind, and why has he been largely overlooked by history? Stick around, because today we're pulling back the curtain on the phenomenal life and legacy of Arnold Sommerfeld. Born in 1868 in Königsberg, Prussia, the same city as the great philosopher Immanuel Kant Sommerfeld, showed early brilliance in mathematics and the physical sciences. He studied at the University of Königsberg, where his talents quickly became apparent. But unlike many of his contemporaries who focused solely on theoretical work, Sommerfeld had a unique gift. He could bridge the gap between abstract mathematical theory and real-world physical problems. This dual mastery would become the hallmark of his entire career. His early work wasn't even in quantum mechanics. He made significant contributions to the theory of diffraction, and even worked on the theory of lubrication for railway cars. This practical, engineering-focused mindset was unusual for a top-tier theoretical physicist, but it gave him a powerful and unique perspective. It was this ability to connect the theoretical with the practical that would make him such an extraordinary teacher. In 1906, Sommerfeld was appointed to the prestigious chair of theoretical physics at the University of Munich. This is where the magic really began. He transformed the department into a world-leading center for theoretical physics. His lecture style was legendary. He didn't just recite formulas from a textbook. He built concepts from the ground up, showing his students how the elegant language of mathematics could be used to describe the beautiful, complex dance of the universe. His seminars were even more famous. They were intense, collaborative sessions where students were challenged to tackle the most cutting-edge problems in physics. Sommerfeld created an environment not of a stern professor dictating to his students, but of a master craftsman guiding his apprentices. He chose his students carefully, looking for that spark of curiosity and intellectual horsepower. And what a group of apprentices he gathered. Let's just list a few of the names that passed through his tutelage. Werner Heisenberg, of the uncertainty principle fame. Wolfgang Pauli, known for the Pauli exclusion principle. Peter Debye, who won the Nobel Prize in chemistry. Hans Bethe, who would go on to explain how stars shine. The list is simply astonishing. 4 of his doctoral students and 2 of his postdoctoral students went on to win the Nobel Prize. It's a record that's virtually unmatched. Heisenberg himself said that he learned more from Sommerfeld than from anyone else. Sommerfeld's gift was in identifying a student's potential and then pushing them, challenging them, and providing them with the tools and problems that would allow their genius to flourish. He wasn't just teaching physics. He was teaching how to think like a physicist. But Sommerfeld wasn't just a teacher. He was a pioneering researcher in his own right, making crucial contributions to the burgeoning field of quantum mechanics. At the time, Niels Bohr's model of the atom was a revolutionary step forward, but it was incomplete. It described electrons in simple circular orbits, which couldn't explain many of the finer details seen in atomic spectra. This is where Sommerfeld stepped in. In 1916, he refined Bohr's model by introducing 2 major ideas. First, he proposed that electrons could move in elliptical orbits, not just circular ones. This was a more realistic and general description of their motion. Second, he incorporated Einstein's theory of special relativity into the model. He realized that electrons moving at high speeds near the nucleus would experience relativistic effects, and this would subtly change their energy levels. By introducing these concepts, along with a new quantum number called the azimuthal quantum number, Sommerfeld was able to explain the fine structure of spectral lines, tiny splits in the lines that the Bohr model couldn't account for. It was a masterpiece of theoretical physics, beautifully combining classical mechanics, relativity, and quantum ideas. The Bohr-Sommerfeld model, as it came to be known, was a critical stepping stone towards the full, modern theory of quantum mechanics that would be developed a decade later by his own students. Like Heisenberg and Pauli, he also introduced the fine structure constant, a fundamental dimensionless constant that characterizes the strength of the electromagnetic interaction. Today, it's one of the most important numbers in all of physics, and it came directly from Sommerfeld's work. So, this brings us to the big question. With all these groundbreaking contributions and his incredible success as a mentor, why was Arnold Sommerfeld nominated for the Nobel Prize 84 times between 1917 and 1951 without ever winning? There are a few theories. One is a matter of timing and temperament. Sommerfeld was a transitional figure. His work, like the Bohr-Sommerfeld model, was a brilliant bridge between the old quantum theory and the new quantum mechanics. It was incredibly important, but it was soon superseded by the more complete theories of Heisenberg's as matrix mechanics and Schrödinger as wave equation. The Nobel Committee has often favored the final revolutionary breakthrough over the crucial incremental steps that make it possible. As one physicist put it, Sommerfeld was like a colonel training generals. Another reason might be his sheer breadth. He worked on so many different topics, from hydrodynamics to X-ray physics to quantum theory, that it may have been difficult for the Nobel Committee to pinpoint a single prize-worthy discovery. He was an architect of the entire structure of modern physics, rather than the creator of a single shiny pillar. Even Albert Einstein, a close friend and admirer, advocated for him. In a letter, Einstein wrote, "What I especially admire about you is that you have, as it were, pounded out of the soil such a large number of young talents." Einstein recognized that Sommerfeld's greatest contribution might not have been a single equation, but the entire generation of physicists he cultivated. Sadly, Sommerfeld's later years were marked by the rise of the Nazi regime in Germany. He was a staunch opponent of their ideology and the Deutsche Physik movement, which sought to dismiss the work of Jewish scientists like Einstein as Jewish physics. Sommerfeld bravely defended his colleagues and the integrity of science, but he was eventually forced into retirement in 1935. He watched in dismay as many of the brilliant minds he had nurtured were forced to flee the country. His life came to a tragic end in 1951. At the age of 82, while walking with his grandchildren, he was struck by a truck and died from his injuries. It was a sudden and unfortunate end for a man who had navigated the most turbulent decades in both physics and world history. So, while Arnold Sommerfeld may not have a Nobel Prize to his name, his legacy is arguably far greater. It's written in the foundational equations of quantum mechanics. It's reflected in the glow of the stars, explained by his student Hans Bethe. It's embedded in the uncertainty principle of his student Werner Heisenberg. His influence is everywhere. He was the ultimate scientific mentor, a master teacher who understood that the true measure of success isn't just your own discoveries, but the discoveries you inspire in others. He shows us that greatness isn't always measured in medals and awards, but in the knowledge we share and the minds we ignite. The story of Arnold Sommerfeld is a powerful reminder of the quiet, foundational work that makes revolutionary breakthroughs possible. He was the root of a tree whose branches reach the very pinnacle of science. Thanks for watching. If you enjoyed this look into one of history's hidden scientific giants, be sure to hit that like button and subscribe for more stories from the world of science. Let me know in the comments who you think is another unsung hero we should cover next. See you in the next video.